here at my home school, the Humanities and Communications Magnet at Lincoln High School, and I'll be your guide on a fantastic trip that my classmates and I took earlier this year. When we first arrived in China, it was like being in another world. We stayed in Beijing, but as a surprise, we were flown to Harbin, China, where we saw a city made entirely of ice. It was awesome.
This particular group, you've been chosen as leaders here at Lincoln.
The World Classroom offers students an opportunity to go outside the classroom and learn about people, cultures, and languages around the world. It offers them the opportunity to actually visit with the native people.
The students themselves were charged with presenting a new technology to China. So what we did was each of the students had a theme of Western culture that they were going to showcase the students to. So the students themselves are actually charged with going over and showing the Chinese how to use this web tool.
The stuff she thinks is important, she put it in order.
In education, very good. Excellent. Very nice.
See, look, it's like this, like, let's say. Chinese students naturally try harder than we do because they feel like they have to be the best at everything. Being average is not an option. Many feel that when they're in high school, they have to work hard to get into a good university. If they're accepted, they then have to work harder to graduate in order to have good careers. Working with the Chinese students to do our themes and work on our web pages, we use a ThinkLess, which is a web page building tool, and we use the Intel thinking tools. And so I was astonished when they got finished with their work, because I'm like, wow, you did that in this little amount of time.
For students traveling abroad for the first time, this is a new experience. They're unaware of what's involved in traveling and the preparation that it takes. Through private funding, through grants, and various other opportunities, we're able to take the students outside the classroom. We feel that it's important to allow all students to participate on the trip, whether or not they have the funds or not. So most of the students put in very little money into the program, but we encourage them to put in time, effort, and work for their position on the trip.
There was one part in Harbin where we had a chance to slide around a frozen lake and then slide down this like toboggan type thing, which the kids kind of enjoyed. And really it's interesting because they get a chance to get out there and just play and be kids.
When we were walking up the wall, it was like we were in awe. You couldn't believe that you were actually there, that our feet were actually planted on this wall, and it's so historical and it's so amazing. It's like we're really there and we're walking up the wall. I really enjoyed the opportunity to share aspects of my culture and learn about life in China. One of the best ways to experience another culture is to talk to people from other parts of the world and get to know them.
We all have the same goals in mind, and that is to educate our students, expand their minds, and become worldwide leaders in the community. We can do this, and we can extend outside the classroom.
I really consider myself very fortunate for the opportunity to visit China. I saw great and wonderful things, but most importantly, I made new friends. Well, that's it for now. Back to you, Dale and Joanna.
One day in the city of Dallas. 516,000 alarm clocks wake up the city. Millions of cars commute to work, and 2,500 planes take to the sky. One day in the Dallas Independent School District, a masterpiece is perfected. Records are broken. New worlds are explored. And the promise of tomorrow becomes a reality. Think you know DISD? Think again.
What's up, you guys? My name is Daryl, and we're where it all happens behind the scenes of Calculus Live. Thanks for tuning in for today's show. But before we get started, we just want to cover a few ground rules. So let's head over to my man Ivan for more.
Okay, good luck on your problem. Okay, ground rules. Let's see. You have to call in. Pick up the phone, give us a dial, give us a ring. I mean, we really want to hear from you. The number to call is 972-925-3123. Take a picture, write it down, just give us a call.
Number 2, when you do call in, step away from the television. It really hurts our ears and it sends off a really bad tone. See what I mean? So, when you call in, step away from the television. I thank you, our hosts thank you, and our ears definitely thank you. And another thing, when calling into the show, please do not use cell phones. Cell phones do not work too well with our audio system here in the studio. They give off a really bad signal and we have a hard time hearing what you're saying. So remember, no cell phones. Another thing that we want all of you out there watching to know is that you could be on TV. That's right, your face could be on the tube. Send us a picture, whether it be an individual photo or a photo of your entire class. We'd love to see you, and so would everyone else out there watching. Either mail it to us through interdepartmental mail at DISD Box 379 or drop us a line at calculuslive@dallasisd.org. Okay, well, it seems like it's just about time for the show to get started, so I have to say goodbye for now. But don't forget to call in for your chance to win all sorts of cool prizes. So get set for our all-new edition of Calculus Live.
Welcome to Calculus Live. I'm your host, June Harmon. Call in and we'll work calculus problems together. Let's meet my student assistant for today.
I'm Rachel Einstein. I am in Mr. Harvey's AP Calculus AB class at Woodrow Wilson High School, and I plan to attend Colgate University.
We're counting the calculus exam on May the 3rd. Rachel, how many days do we have to prepare?
There are 21 days.
Yikes.
Let's get ready to rumble!
We should get ready to rumble. 21 days? Oh my goodness. We're getting right to work. Rachel, who is our first caller?
Our first caller is Eduardo from Sunset.
Hey, Eduardo. How are you? Eduardo, how are you?
Hello.
Hi, how are you?
I'm fine. What's up?
I tried to come see you guys yesterday, but I drove too slow. Did Mr. Cousin tell you?
Nah, he didn't tell us.
Well, I came by to deliver the prize to Veronica, and I was hoping to see everybody, but I have to leave from my school, and you know they have traffic laws, right?
Yeah. Well,
So I had to obey the traffic laws. Eduardo, we're going to show your picture here.
okay.
There you go.
You got a haircut!
Did you?
Yeah.
Tell me about your haircut, Eduardo. What kind of haircut did you get?
It's tape fade.
Say it again.
A taper.
Ah. So is this like for a special event, like you got prom going on?
Oh no, it's because I got a job and they told me to cut it off.
You got a job and they told you to cut. Well, good for you. So you took care of business, huh?
Yeah.
What kind of job you get?
Cashier.
Excellent. Well, you know what? We all have to fix the dress code, don't we?
Yeah.
Yeah. They may tell me to cut my hair off. You never know. You ready to work a problem?
All right.
All righty. Did you say not really? Or did you say, yes, I'm ready, bring it on?
Yes, I'm ready.
Thank you. All right, here we go. I'm going to have you do a two-step problem. Are you ready? Would you integrate the sine of t from 1 to 3x? That's a 3x. It's probably a little hard to see. So what do you get when you integrate sine?
Negative cosine.
Good job. And then I'm going to put the plug-ins, just like it says. All right, now what do you get?
Negative cosine 3x.
Take away negative cosine of 1, right?
Uh-huh.
That's just a number, isn't it?
Yeah.
I don't even know what it is, but it's a number. Okay, good.
Zero.
Now, would you take the derivative of your answer?
I can't see.
It's negative cosine of 3x. So what's the derivative of cosine?
Sine?
That's right. So it's sine of 3x with a chain out of what?
3.
3. And what happens to this number when you take the derivative? What does it give you? Every number goes to...
0.
That's right, 0. Now, that is perfect. Eduardo, you did a fabulous job.
Okay.
Now, I want you to look at this problem. Do you
No.
see it?
Yeah.
I want you all at once to take the derivative of the integral. Now, do you know what to do?
Sine 3x
Sine 3x.
times 3.
That's the same answer you got a while ago, isn't it?
Yeah.
So you did it all at once because you know the shortcut. They're going to ask that. That is a low-performing question. You're going to get it right. Yay.
Yay.
That's a good thing. Hey, thank you for calling.
Hey!
Hey, good luck on that job. I hope you do really well and get a raise.
Okay.
All right, bye-bye.
All right, bye.
Who's our next caller, Rachel?
Our next caller is Ruth from Adamson.
Hey, Ruth.
Hey.
Did you get your gift card?
Yes.
Excellent. Have you spent it already?
No, not yet.
No, you're saving for a rainy day, right?
Yay.
I hear all the Adamson women are going to get 5s. Is that what you hear?
Yes, we are.
Excellent. I can't wait to see that. That's going to be great. All right, let's get my problem ready here. I've got to zoom out. Okay, you ready? Here we go, Ruth. If the derivative h prime of x is x squared minus 2 over x for all x not 0. Wonder why they said that.
Huh?
Why did they say for all x not 0?
Because if x goes on the bottom, you have an undefined.
That's right. We can't let that happen in our real world system of numbers. Okay, I want you to find the x where the graph of h has a horizontal tangent. This is h prime. Where are the horizontal tangents? What are you looking for?
What was that out of here?
Where are the horizontal tangent? This is your derivative. What about the derivative makes a horizontal tangent line, or a slope of what?
When the first derivative is equal to 0.
That's correct. So which part equals 0, the numerator or the denominator?
The numerator.
The numerator. So what are you going to say? X squared minus 2 is 0. What is that going to give you for x?
It's the square root of 2.
That's right. X is, and you want to elaborate? Say it one more time.
Plus or minus.
That's perfect. Plus or minus square root of 2. Now, let me ask you another question. Those are two critical numbers, true?
Yes.
Where does this function have an asymptote?
At 0.
So you need to consider x is 0 on your chart. So let's make a chart. Negative root 2, 0, and root 2. I want you to take the derivative and tell me about the function. Did I label it the way you do, or do you like to put it the other way? Is that okay? Okay, good. I want you to tell me if these are local max or local mins. I'll remind you these were 0 derivatives, and this is that undefined spot. But we got to have it on there to keep our intervals. That's an asymptote. We know that, right?
Yes.
So I'm going to put vertical asymptote. Okay. How are you going to test for max or min?
You're going to plug in a number to the left of your critical numbers.
That's right. Where would you like to start?
Negative 2.
Over here?
Yes.
Okay. What did you say? I'm sorry?
Negative 2 use.
Negative 2 sounds great to me. I'm going to write it down here. It's x squared minus 2 over x, right?
Yeah.
And as you plug in negative 2, what's going to happen? Positive or negative?
Negative.
I think that's right. Function's going down, all right? When you plug in, what do you like between negative root 2 and 0?
1.
Negative 1?
Uh-huh.
Okay, good. When you plug in negative 1, what do you get?
Positive.
Positive. Function's going up. Is this a max or a min?
It's a min.
It's a min. Now remember, this one is a place where it's undefined. It's got an asymptote, okay? Or the derivative does, anyway. All right, what do you like over here?
1.
1 sounds good to me. When you plug 1 in, what do you get?
Negative.
Function's going down. And when you plug in something bigger, what do you get?
Positive.
Function's going up. So what did you find at negative root 2 and root 2? They were what?
Minimums.
Local minimums. Can you tell me why they're local minimums? Why is the reason that they're local minimums?
Because they change. Huh?
Keep going. Because what? Are you there still?
Yes.
Okay.
They change from negative to positive.
And
slope.
tell me what changes. You're exactly right.
F prime.
F prime changes sign.
From negative to positive.
from -5. That is perfect. They want you to tell a calculus reason. They don't want you to say the graph goes down and then up. It does, but that's not the calculus reason, okay? Hey, Ruth, you did a great job. You might win another prize, right?
Yes, I am.
All right. Let's
you.
have a bell. Thank you for calling in. Let's have bells on that one. Thank you very much. Who's our next caller?
Our next caller is Crystal from Carter.
Hey, Crystal.
Hi, how are you doing?
I'm doing fine. What's going on at Carter? Anything going on at Carter?
Just everyday school.
Just everyday school. Y'all had prom already?
No, I promise not until May.
Oh, in May. After AP, I hope?
Yes.
Excellent. I don't mind if prom is after AP. Excellent. Excellent squared, right? All right. How do you feel about taking derivatives? Do you like taking derivatives?
Sure.
It's more fun than going out on dates, right?
Yeah.
Excellent. Good answer. You know, you can always take your calculus with you, and if the date is bad, pull out that calculus, and you can always have a good time, right? I know. Okay, here we go. The derivative is, I've got x squared sine of 3x, so what are you going to do? Oh, I'm sorry. I'm doing something.
Can't see it. It's 3x squared.Hold on.
This is x squared and the
Okay.
sine of 3x. It's hard to see sometimes, I know.
Okay. So it'll be x squared times 3 cosine of 3x. No, 3 cosine of
Yeah, you said it right. I was about to make a mistake. Perfect. Plus
sine of 3x times 2x.
times 2x. You did a beautiful job. You did 1 times the derivative of the other. You remembered the chain out. Plus the second times the derivative of the first. That is beautiful. You might pull x out. You could do something like that, couldn't you? If they want you to. Hey, great job. Let's have bells all around.
All right.
I'm wishing you make a 5. Who's our next caller?
Our next caller is Jessica from Skyline.
Hey, Jessica.
Hi.
How are you? Who's your teacher? What a round of applause, Jessica. That is amazing. Who's your teacher?
Miss Johnson.
Miss Johnson. Do we have your picture?
Yes.
Okay, we're going to pull it out. Here it is. Oh, you called before, Jessica.
Yeah.
I like this picture. Calculus savvy. Excellent. You look good. How's calculus going?
How's what?
How's calculus going for you?
Doing good.
Going good?
Yeah.
All right. Hello, everybody. How about, this is on every year, and I think we can get really good at it, and you probably already are really. Uh-oh, wait a minute. I can't.
Oh, wow, you look pretty cool.
There we go. All right, the limit as x goes to infinity.
Right.
Can you see it? Can you see it okay?
Yeah, I can see it.
Limit as x goes to infinity. Do
Yeah.
you know what to do?
Yes.
I hope this is an easy one for you. What do you get?
3/8.
I think that's almost correct.
Oh, -3/8.
There you go. Good job. Watch that negative sign. That was perfect. How did you know that so fast? What did you look for?
They have common exponent.
The common exponent, the biggest power at x, top and bottom matched. The other, like riffraff, you know,
Right.
like sands in the hourglass time, right? What is that
Yeah.
thing? Sands in the time, you know, one of those. Okay, very good. Don't forget though, because you know what? I bet they'll put 3/8 if we forget the minus sign. What do you think?
Yeah.
Yeah, I think so too. All right, thank you for calling in. You guys call back.
All right, bye.
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 Who's our next caller?
Next caller is Blanca from Kimball.
Hey, Blanca.
Hello.
Hi, how are you?
Good, and you?
I'm very well, thank you. So how's everybody over at Kimball? How's Miss
Great.
Brzezinski?
She's doing good.
Good. Is
Getting
she-
ready for some ice cream.
Oh, good. I know you got to wait for her to get ready for the moment to serve ice cream, right? There you go, Blanca. Excellent.
Wow, you look pretty cool.
Hey, Blanca.
Yeah, baby. Yeah.
Blanca, are you coming to the session where you take the practice exam at Townview on the 21st or the 22nd?
Yes,
Excellent. Which time are you coming? Friday night or Saturday?
Friday. I
Friday.
have a soccer tournament to go to.
Oh, you
so
do? Well, good luck on the soccer tournament.
Thank you.
But so I'm glad you're going to come Friday night. That'll be great. I'll be there Friday night. I'll actually be there Saturday too, but I'm going to be there Friday night. Okay, I've got a little separate. Oh, I shouldn't tell what it is, right? Take that back. I take back what I just said. I've got a differential equation. dy dx equals -xy squared over 2. Find the solution y equals if f of -1 is 2. Do you know what to do?
Separate the variables.
Excellent. Separate the variables. Tell me what to write.
we're going to multiply by dx.
Okay.
So it's going to be dy equals negative x y squared over 2 dx.
Perfect. Now
Then we're
what?
going to divide by y squared.
Okay.
So y squared, dy over y squared equals negative x over 2 dx.
So far, so good. That looks great. Now
Then we're
what?
going to integrate to take off the dy and dx.
Okay.
And then we're going to bring up y squared and be integrate y negative squared equals integrate negative x over 2 dx.
Perfect. You are getting it set up just the way you like it so that you can integrate. Go right ahead.
We're going to bump up y negative squared to y negative 3 over 3.
All right. Now, are you adding 1?
Oh wait, oh yeah, we're adding 1. So
Okay.
It's gonna be, okay, so it's going to be y to the negative 1 over negative 1
Perfect.
equals, we're going to bring out the negative,
Okay.
and then it's going to be x squared over 4
That's right. 2 times 2 is 4. And then plus?
plus
What's that famous letter we like?
c.
Plus C. Very good. You know what? You did that beautifully. That looks really good. Even if you've stopped here, you've got a lot of points, but you're not going to stop. You're going to keep going.
We're going to bring down the y.
All right.
So it's going to be negative 1 over y equals negative x squared over 4 plus c.
Okay. Now, I don't know if you remember the ordered pair, but I'm going to write it here for you. Negative 1, 2.
Okay, so we plug in the points, and it's going to be negative 1 over 2
Great.
equals negative 1 over 4 plus c.
Perfect.
And then that'll be, so we're going to add the 1/4.
Okay.
So it's going to be negative 1, okay, yeah.
That's
equals
great.
c. And then we're going to find a common denominator,
Okay.
and it's going to be negative 2, no, it's going to be 4 at the bottom, and then it's going to be 3 at the top with
Now,
the negative.
Let's
Oh,
see.
wait.
Let me look. I think you said it a minute ago, actually. 2 times 2 is 4, so 2 times negative 1 is negative 2.
Yeah,
And you said it a minute ago. I just got behind. And so what is C equal to?
it's equal to 1 over 4.
And plus or minus?
Negative.
Negative 1 over 4. Now let's go back up here and write the whole thing. Negative 1, oops, I'm going to try to get both of them in the picture, equals negative x squared over 4 minus 1 over 4. Ooh, we're getting close. Now what do you think we ought to do? We need to bring it on home.
We're going to, negative 1 over y equals a big bar over 4, and on the top it's going to be negative x squared minus 1.
Perfect. Now what?
We're going to flip the signs.
Okay.
So it's going to be 1 over y equals x squared plus 1 over 4.
And
then we're going to reciprocate.
oh, perfect. I like that word. Is that really a word? Reciprocate. In other words, you're going to take these equals and they're still going to be equal, right?
Yes.
Y equals 4 over.
X squared plus 1.
You know what? That is a hard problem, and it's usually the last one on the exam. If you can nail this as well as you have today, that is beautiful. That's going to be 6 points right there out of the 9, isn't it?
Yes.
You did a perfect job. That's extra bells and extra rounds of applause. Hey, thank you so much for calling in. You did a wonderful job. That's great. Thanks for calling. Who's our next caller?
Marco from Sunset.
Hey, Marco.
It's not Marco. He chickened out. He punked out.
He chickened out, so
Yes.
who is this?
Yvonne.
Yvonne.
Yes.
We're not going to show Marco's picture. We're going to show Yvonne's picture, okay?
Okay.
All right, we'll get your picture in just a minute, Yvonne.
Okay.
I talked to your principal yesterday. Did you know that?
Excuse me?
I talked to your principal yesterday.
Oh, really?
He's a nice principal, yeah. I was talking about how we're so thrilled with the summer program y'all are doing. You guys are just tearing it up with a good summer program. Are you Yvonne Diaz?
Yes.
Excellent. We got you. Here we go. All righty.
Oh, wow, you look pretty cool.
Yeah, baby.
What's your favorite sound effect?
Oh, I have no idea.
I like the one that sounds like Joey myself. You know which one I'm talking about?
Yeah.
Yeah. Okay, this is one that if we get this down, we are in really good shape. The derivative of v is 3 square root of t. V of 1 is 7. V of 4 is who knows. You know what this one is?
I don't know. A PVA?
Let's see if Rachel knows what it is. Rachel, do you know what kind of problem this is?
Fundamental theory of calculus.
Fundamental theorem of calculus. All right. This is setting the derivative and the 2 points equal. For example, if I wrote this, integral from a to b of f prime equals, would you know what to put? F of b minus f of a, right?
Oh, yeah, right.
Yeah, so you know that. So what we need to do, and this is one of those that at first we all think, what? But then we look at it a little bit. We want v of 1 and v of 4. So if we integrate from 1 to 4, how did I get those numbers? I looked right there.
X, yeah.
3t, is it okay if I call it to the 1/2?
Yes.
And I'll get v of 4 take away v of 1. Okay, good. Now you take over. What do I get for v of 1?
7.
7, that's right. What do I get when I integrate? That's going to take a little work. Are you ready to integrate?
Sure.
Okay, go for it. I hope this works out, don't you?
3t to the 3/2.
That's right.
And then times 2/3.
Okay, good. I like that. And then we've got our plug-ins.
Right.
Okay. Well, this is looking kind of messy, but we have high hopes. What can we do here?
Cancel the 3.
Okay. So I'm going to rewrite it 2t to the 3/2 with plug-ins 1 and 4. Let me see if my pen, if I can get it to not be so fat looking, okay?
Okay.
All right, and so what do I do to plug in? It's 2 times, well, that's too thin, isn't it?
Yeah.
Never mind. I'll go back to the fat one.
4.
It's 2 times 4 to the 3/2. Take away.
2 times 1 to the 3/2.
Equals, and I got to remember I'm still dealing with v of 4 minus v of 7. All right, let's do this one first because it's easier. What's 1 to the 3/2?
1.
And take away 2 times 1 is that, okay?
Yeah.
So far so good. We've just about got this licked. All right, 4. What are you going to do with this 3/2 talk? Start with the square root. What's the square root of 4?
Square root of 4.
Uh-huh.
2.
2. And 2 cubed is?
8.
8. And 2 times 8 is?
16.
There you go. So start, you know why I start with the root? I could actually start with the cube, but that gets to be a big number. I don't really want a big number. It'd be harder to think about. That would be 4 cubed is 16, and then take a square root. I'd still get 8, but I think it's harder. So start with your root.
Okay.
And then get it. Okay, now 16 minus 2 is how much?
14.
Equals v of 4
minus 7.
minus 7. And what's v of 4?
7.
Really? 14? What do you do with this minus?
Well, you had 7.
There you go.
Oh, I'm sorry.
That's okay. What do you get?
21.
You just wanted to see if I was paying attention. You get 21. This problem can be in your pocket with a little more practice. And I'm saying that for all of us because we get 2 pieces of information about the function and we know the derivative. One thing is missing. We can solve these using our fundamental theorem of calculus, okay?
Okay.
All right. Listen, you did a good job. Thank you for working that out with us.
Okay, thanks.
Bye-bye.
Bye.
Who's our next caller?
Molly from Bryan Adams.
Hi, Molly. Hi. How are you?
Good, how are you?
I'm fine. Didn't you win a gift card?
Yes.
Did you spend it?
Yes, I did, on some shoes.
You're on some shoes?
Yeah.
Oh, I'm impressed. What kind of shoes?
On some sandals, and they're blue, and they have beads on them.
Ooh, I like sandals with beads on them. That sounds wonderful. Now, they don't violate the dress code, do they?
No.
Oh, okay, good. I'd want you to be a really law-abiding citizen. How's Miss Arthur?
She's good, but she's not here.
She's not. Is she okay?
I don't know. She's just not here. I think she is.
Oh, okay. Well, sometimes she has senior stuff. You know, she's senior sponsor, isn't she?
Yeah.
Are y'all having a prom this year?
Yes, on the
I was kidding.
29th.
Right before AP, cancel. I'm sorry, y'all will have to cancel prom.
No, I don't think that's gonna happen.
Oh, okay. Well, will you promise to get home early and get a good night's sleep?
I'll see what I can do.
Okay, thank you. That's all I can ask. Okay, Molly, you ready? I got a problem here. I've been filling through all my problems, and this is the one I like best.
Okay.
Can you see it? Not yet, can you? We'll wait. Here it comes. Ready or not?
Okay.
I like these today. Can you tell I'm on a theme? This is a theme show, differential equations. Consider the differential equation, dy dx, 3x squared over e to the 2y. Are you getting nervous?
Huh?
Are you getting nervous?
No.
No, of course not. You're cool. You're calm. You're collected. You know
Right.
this stuff.
Separate and integrate, right?
That's exactly right. Separate and integrate. So tell me what to write.
Okay, 3x squared dx.
Perfect.
And then, e to, is that to the 2?
That's e
Y.
to the 2y.
Okay, yeah, that with the dy.
That is exactly right, and that is 1 point already. If you can't do another thing, you got that point, right? Of course,
Right.
you can do other things. Now what?
Integrate both sides.
Which side's easier to you?
The easy button side.
Okay, go for it.
Okay, that's what? The other side is e
Uh-huh.
2y to the 2y times 2.
Now, you need a 2 right here, and you don't have it, so what do you need out front?
Offset with the 1/2.
Perfect. That's exactly right. I think that's the hardest side, don't you? But you've got it done. Now let's go to this one.
Okay, that's 6. Oh, just kidding. That's 3x to the 3rd over 3.
Right, so can we say x to the 3rd?
Yes.
Plus what famous letter?
C.
Yay. So far, so good. Now what?
Now, fine. Okay, don't you need to plug in some numbers?
I think that's a great idea. Look, guess what? They gave us some. They're going to have to give you some numbers if they want you to find plus C.
Right.
Okay, then here they are, right here.
Right. Plug in 1/2. Do you plug in that?
Yes, you do. Where do you plug it in?
For the y.
That's correct. 1/2 e to the 2 times a half. I'll just write that so you can think about it.
Okay.
And so then what do you plug in for x?
0.
Plus c. So if we can figure this out, we got c.
Right.
What's 2 times a half?
1.
So that's e over 2 is c. Do you agree?
Mm-hmm.
E to the 1, or e, 1/2 e. You could say it that way. All right, I'm going to move down here, and I'm going to rewrite. That's 1/2 e to the 2y equals x cubed plus e over 2. Did I write what you said earlier? I think I did.
Mm-hmm.
All right, now, how are we going to get this thing to y equals? It looks kind of messy.
Can you divide the half over?
Well, I think that's a good idea. You want to multiply through by 2?
Yes.
Let's do that. E to the 2y equals 2x cubed plus e. I think I'm okay with that. What do you think?
Yes.
Okay.
And then do you L in it?
I like that. We L in it. We L in it. All right, and then what?
Okay, and then doesn't the ln and the e go off?
That's right, and you can think of it as bring the 2y down front, and the natural log of e is 1, so that's good. We got this.
And then you divide it by 2.
And then you divide. I'm going to do that in a brief step here. That is perfect. It's worth practicing on those to get really good at it, because that's going to be on the test, isn't it?
Yes.
You did a fabulous job.
Thanks.
Tell Ms. Arthur you get extra credit.
Okay, thanks.
Bye. Thanks for calling. Who's our next caller, Rachel?
Minerva from Adamson.
Hey, Minerva. How are you?
I'm doing fine.
Good. I hear every calculus teacher in town was over at Adamson yesterday. Is that what you heard?
Yes.
I was there, Mr. Trevino was there, Miss McMullen was there, and your teacher, Mr. Bentley, was there. It's like we were like having a convention, weren't we? Yeah, there you go. All right, we may have to come back and have another convention. I like y'all's new room. That is very nice.
Thank you.
Do you like it? Do you have all your classes in that wing, or just a few?
Most of them.
Most of them. Cool. So it's like a senior wing, right?
Uh-huh.
Okay. All right, here we go. If f of x equals the natural log of 2x plus 8 plus e to the negative 3x, yikes, find f prime of x.
Okay.
How do you find f prime?
You take the
You're gonna do a U substitution, du.
Okay, good. And what is the derivative of natural log? It's
D over U.
du over u. That's right. So what do you want to start with? What would be the easiest thing to do?
Put everything in the bottom.
Yeah, put everything in the bottom. 2x plus 8 plus e to the negative 3x. And now we work with the top. Go for it. 2
minus 3e to negative 2.
Negative 3x. It's probably hard to see.
Oh, yeah.
You brought down the negative 3, e to the negative 3x. And since I kind of wrote all over the paper, yay! That is very good. That is du over u. And that's a great job you did on that. That looks really good. Thank you.
Thank you.
Call back.
Alrighty.
Bye-bye. Who's our next caller?
Kevin from Skyline.
Hey, how are you?
Hello, I'm good.
Skyline
Good.
having a prom this year?
Yes, we are.
When is it?
May 6th.
Perfect. After the
Perfect.
calculus exam.
Woohoo!
Like
Is-
the way y'all think.
Is Ivan there?
Ivan's here.
Tell him I said hello.
I will tell Ivan you said hello. Everybody. Ivan says hello back.
All right.
All right. I've got a problem here for you. Who's your teacher?
Ms. Johnson?
We got your picture?
Yes, you do.
Well, let's see it. Let's get that picture showing. Here we go. Hold on. I got to find you. Okay. Perfect.
Oh, yeah, that's beautiful.
That is a beautiful picture. You are correct, sir. You look very calculus smart, don't you?
Yes, I do.
All right. Let me get this where you can see.
You look pretty cool.
I may have made this too little for you to see. Let's see. We're going to try. All right, here we go. I want you to tell me what you would do on this. You've got y equals the square root of x. I'm going to mark that so you can see it a little better. And you've got y equals e to the negative 2x, okay?
Okay.
And the line y equals 1. The line x equals 1, okay? And we've shaded the region. And I want the area between the curves, okay?
Okay.
Now, what are you going to need to know first?
Intersection.
The intersection. I bet you're using an 89, okay? Is that
Yeah.
right? You use your 89. I'm going to have to put up my little old 84, okay? That's what I brought with me today.
Okay.
So I'm going to plug these into Y1 and Y2, and you plug them into yours, and we'll see if we get the same intersection, which I hope we will. It looks like mine needs a bath, doesn't it? Needs a little shower here. Okay, I'm going to do square root, if I can find it. Square root of x, and e to the negative, what did I say, 2x?
Right.
Okay, does that look like I typed it right? And you can tell in yours if you've typed it right, can't you?
Yes.
That pretty print's nice. All right, I'm going to do a zoom 4 and see how it looks. Well, it looks kind of like that one. And then I think I'm going to close my window down, so I'm just looking at, oops, that's not it. So I'm just looking at what I want to look at.
Right.
And you wouldn't have to do all this. You could just look at what you got, but there you go. Now I'm kind of looking at the right picture. Okay, tell me what you need to find. You said you need to find
The intersection.
the intersection. So you do your calculator and I'll do mine. Second cal, 5 for me. Enter, enter, enter. And you got to go left and right and get yours.
Right.
What are you going to do with that intersection point?
We're going to, set it equals 0.
Well, and you want to store it, don't you?
Right.
You want to store it. So
we can read
I'll
it.
store it on mine. Second quit and go home. Store is alpha A. I'm going to call it alpha A. Is that the number we had? 0.3054. Why am I doing that?
So that we can find the exact point and not round.
Exactly. If we round, are we likely to lose some credit?
Yes, we are.
Yes, we are. So now we've got it ready. Now let me remind you, my y1 is the function on top and my y2 is the function on the bottom. So what do you want me to do to find the area between the curves?
Do the top, subtract the bottom.
Say it again.
Top, subtract bottom.
That's right. Top, subtract, bottom. So what calculator feature am I going to need?
The integral feature.
That's right. So I'm going to do Math 9 on mine, and you'll do what you do on yours. Now, you could type them in, couldn't you? But we've got them, so I'm going to do y1 minus, you said top take away bottom,
Right.
y2,
Right.
comma. In my machine, I got to tell it the variable.
Respect to x.
There you go. And then what do I want to go from?
Want to go from A,
Alpha A
alpha A to the 1.
to 1. That's exactly right. And now when I hit enter, yay!
Right.
I got the answer. Now let's go back to our paper. I'm going to keep this answer off to the side here so I can look at it. Now we need to show what we're going to write it so we'll get credit. Area equals. What do you need to write?
Area equals square root of 2, the integral.
The integral.
Right. From A.300.
That's right. I like that. 0.300, and I'll put ... so they'll know I'm not rounding. Good. To what?
1.
1. You could also call it, I could call this area, you could call it A as long as you tell them.
Okay.
As long as you tell them. Now what do I put?
Square root of 2.
Now I don't want to put a 2, I want to put X, right?
Okay, well, X.
That's right. Take
Minus
away.
E to the negative 2x.
And what else do I need?
The dx.
I need the dx. And then all I need to do is show, if this is calculator friendly, show the setup and then show the answer, 0.3503. But you can actually stop with how many?
3.
You can just stop. You do not have to round, do you? That's called truncating. You need to give them 3. Will they count?
Places.
Say it again, 3 decimals, that's right. If it's something other than 0, don't go giving them 2 or you'll lose the credit, okay? That would be sad, wouldn't it?
Yeah.
Get it all right and lose your credit. So physics people need to really remember, because you're used to other rules, and I'm not even going to talk about those rules, am I?
No.
But we go 3 behind the decimal. Remember to show the setup. I like the way you said integrate from 0.300 blah, blah, blah to 1. You didn't say function integrate. Don't write that, do you?
No.
You don't get any credit for knowing the calculator language. You have to use it, but you don't want to write it down. Hey, you did a great job. I liked everything you did on that problem. Perfection.
Thank you.
Extra credit. Round of applause. Bill.
Thank you.
There you go. All right, who's our next caller?
Hector from Sunset.
Hey, Hector.
Hello.
How you doing?
I'm doing fine.
I enjoyed going to Sunset. You know, everything looked a little different.
Yeah.
Y'all just did some remodeling since I've been there last.
Yeah.
Here you go, Hector. Got your picture. Excellent. Let me zoom in. Very nice.
Wow, you look pretty cool.
Yeah, baby.
I wonder who that is. Oh, take it off. Okay. I wonder who that is, Hector. I don't know who that is talking to you.
What do you mean?
I don't know. Is it people in your class
Oh, yeah.
complimenting you? Is that it? Well,
No,
good
they
for
weren't
them.
complimenting me.
Well, they should. All right. Are you the best student in the class? Tell the truth now.
No, I'm like,
Almost?
okay.
You're what?
I'm okay.
You're okay. Hey, okay is good. All right, I want you to help me set this one up, okay? This is y equals the square root of x, and this is y equals e to the, I've forgotten what it is, negative 2x. Okay? It's just like the last problem. And this is that point 300, and we kept on going, and we stored it in our calculator, okay?
Right.
All right. I want the volume of the solid generated when r is revolved about the line y equals 1.
Okay.
Is that okay?
Yeah.
I like to draw that picture. Now, how do you start this problem off?
Okay, I subtract everything by 1.
Oh, you're going to translate the axes, aren't you?
Yeah.
All right, so you're going to go, I'm going to move everything down, and so you're dealing with y equals square root of x minus 1, and y equals e to the negative 2x minus 1. You are taking this picture and you're moving it down so this becomes your axis, aren't you?
Yeah.
Good job. You translated, you moved these functions down 1. What happens when you move them down 1? Minus 1. Okay, now these are your two functions, and what do you do to get the volume of the solid revolving?
I do pi, integrate the, what is it? We're doing next talk, right?
Say it again?
Top minus bottom?
That's correct.
Yeah.
That's correct. Well, let me think a minute. We're doing furthest away, take away, closest away.
Oh, yeah, yeah.
And this
So
is to 1, right?
Yeah.
And I've got this, I need my dots so they'll know. Okay, now, if I look back here, the furthest away is this one. Does that help? That's the furthest away.
Right.
So what are you going to put first?
E to the negative 2x minus 1.
And what are you going to do to it?
Square the whole thing.
Beautiful. Take away.
Minus x, square root of x minus 1 squared dx.
I love that. Now, my audience, some of them are probably going, what? Why is it 1 minus? For those who don't move the axis, you're going to go 1 minus this function and 1 minus this one. He's going to get the very same thing by translating. He took his whole picture and moved it down. That's okay too. You're both going to get the same mathematical answer and both are good to go. I like this technique. Ms. Brzezinski showed me this. I like what she does. Now, we're not going to finish it out. I just wanted to do the setup, but that is a beautiful job. This one is if you translate, if you move the axes so that you're rotating it around X, you just took the whole picture and went down 1.
Yeah.
Good job. That is beautiful.
All right.
Thank you for calling in. You guys call back.
All right.
Who's our next caller?
Avante from Lincoln.
Hi, Avante.
Hello?
Oh, wait a minute. Is it Mr. Calculus?
Yes, ma'am.
Mr. Calculus. How's the Calculus Queen doing?
She chilling.
Huh?
She chilling.
She's chilling. Excellent. Chilling is a good thing, right?
Yeah, it's equivalent to integration.
There's nothing better than calculus, true?
Mr. Calculus.
Mr. Calculus would, of course, say that. So you're going to make a 5, Avante?
Actually, I'm going to make like a 5.5.
They're going to have to make a new score for you, right?
Yeah.
Excellent.
The Mr. Calculus score.
Mr. Calculus is going to get a 6.
Nah, 5.5.
5.5, okay. Yeah, that's good. Modesty. I like modesty. All right, here's a chart for you, and it may be hard to see.
Sure, you guys. Whatever.
Is that a person that works at the Gap, do you think? Whatever. This is X, and this is F prime of X. And you may have trouble seeing that, but this is the derivative, okay?
Okay.
The function F has that's me doing magic. The function F has exactly 2 critical numbers. Can you find those critical numbers?
X1 and X5.
That's right. Those are the critical numbers. Only 2, so there are no more, right? Over which interval is this function decreasing? The function, not the derivative, but the function. Where's the function decreasing?
It is decreasing on the from 2 to 4.
Now go ahead and include the endpoints.
The endpoint.
1 to 5. Good job. Tell me how you knew that, because?
Because the first derivative is negative, that means the function is decreasing.
First derivative negative, function is decreasing. That's calculus talk. Coming from Mr. Calculus, it sounds pretty perfect. That is beautiful. I think that kind of problem is another way they check us on increase, decrease, max, and mins. Good job. Ivante, thank you for calling in.
Okay.
You guys call back.
All right.
Who's our next caller?
Christian from Adamson.
Hi, Christian.
Hi.
Hey, did you have fun was it Speed Zone?
Yes.
Tell me what you did.
Okay, we did a lot of calculus.
A lot of calculus, that's my favorite part.
And then we did we play sometimes too at Speed
Some
Zone.
play. Is that like where you drive cars or stuff?
Yes.
Ooh, and video games?
Yes.
I'm all about video games. Do you believe that?
Me too.
Yeah? Actually, I may have to learn a video game or two. What do you think? I may do
I think
that.
that's a great idea.
I think I should do on May the 4th.
Yeah.
I'm doing everything on May the 4th, right? Why is that? What's May the 3rd?
The test.
The AP Calculus exam. I got a problem for you here that comes right off of exams, okay?
Okay.
They love this problem. You ready?
Yes.
I am too. 10, 9, 8. We're about to move. Here we go. All right. Using the substitution u equals 3x minus 1, take the integral from 0 to 3 of the square root of 3x minus 1 dx and write the equivalent. I didn't give you choices like they will, but I want you to just put in all the u sub for me.
Okay. So we write the integral. Okay, now we put the u equal whatever, and then we put the du.
Okay?
We need the du.
U is 3x minus 1, and I need du. And what is du?
3dx.
3dx. Do I have 3dx?
No.
No. You're going to fix that though, aren't
So
you?
we put 1/3 outside of the
Very good. 1/3 out front. Here's du. What goes in the square root?
u to the 1. Yeah.
Yeah, or u to the 1/2. And now a critical point here. What do we do with these numbers?
We change it to the. We plug it into the u, and then we change it.
Excellent. Plug in 0, and what do you get?
-1.
And plug in 3, and what do you get?
8.
8. And you know what? They'll have an answer choice where everything's right, but they leave 0 and 3. Don't fall for that, okay? This is a low-performing question. Did you know that? You did it so well. A lot of kids across the country, across the world, actually, don't get this problem. So if you get it right, yay.
Yeah, that's good.
That's very good. You did beautifully on that. Change the limits. Don't forget to change the limits. And you handled that DU perfectly. You knew you needed the 1/3. Excellent. Thanks for calling in. Bye-bye. Here's our next caller.
Desmond from Kimball.
Hey, Desmond. How are you? So y'all got a good working TV this time, huh? Oh, that was the other school. I forgot. Here you go, Desmond. Excellent. You look like you know calculus, Desmond. Are you pretending to know calculus?
Yeah.
Okay, pretending is good. I've got a problem here for you. You ready?
Yeah.
What's going on at Kimball?
Nothing.
Nothing? No problem?
No. We're twiddling our fingers over here.
What is that?
We're twiddling our fingers.
Oh, yeah. I know if Ms. Brzezinski is your teacher, I know you have a lot of free time, right?
Yeah.
Yeah, right. Maybe between midnight and 2, maybe. Okay, here we go. Given the function, 3x times e to the x, I want to know about the graph. I want to know where this graph, f of x, is concave up.
Yes.
So what are you going to do?
You have to take 2 derivatives.
I have to take 2 derivatives. Well, let's get started. What's the first derivative?
It's a product rule.
That's correct. And
Correct,
boy wonder. Correct. I like that. That kind of pierced my ear a little bit. All right, so what do you do?
The first is 3x times the derivative of the second is e to the x times 1.
That's right. Good job.
Yeah.
Plus
e to the x times 3.
Great. So I'm going to rewrite it just so you can see, because I kind of smudged it a little bit. Okay, good. That's the first derivative. Now, you said to take 2, so I believe you. You seem to be like a person who tells the truth.
So we take another, it's a product rule again.
Okay. What do you get?
So it's 3x times e to the x times 1 plus 3 e to the x plus 3 e to the x.
Good job. All right. Clean it up for me a little bit. What do you get?
3x e to the x plus 6 e to the x.
Excellent. You want to set that derivative equal to what?
0.
Good job. Now what?
You bring 3 e to the x to the other side.
I like that. What do you get?
X plus 2.
Excellent. Now here's where we have to ask ourselves a question, okay? What do you know about e to the x? It's always positive. It's not going to go to 0, so we can kind of ignore it for the moment. What does go to 0?
X plus 2.
X plus 2? That's right. So what does x equal?
-2.
Very good. Now I'm going to fill in -2. My second derivative tells me about the function. Is that okay to write it that way?
Yeah.
All right, good. I know this is always positive, so I'm going to put my finger over it so we can ignore it, okay?
Okay.
So when I go to the left of -2 and to the right, tell me what's going on.
It's negative.
-4 gives me negative, concave down. And over here, what do you like?
We can do, it's probably positive.
It's positive,
Yeah.
concave up. And the question was, where's the function concave up? So what are you going to say?
-2 to infinity.
Perfect. And don't forget, infinity gets a parentheses. Don't go putting that square thing on. They'll go, ha ha, they think they can get to infinity, right?
Yeah.
So be sure you put your parentheses. You did a beautiful job. That is not an easy problem, is it? But that's the kind they're going to ask.
Oh, okay.
Listen, thank you for calling in. You guys call back. Who's our next caller?
Marco from Sunset.
Hey, Marco. You got your picture? Marco. Excellent. I got to see all my old friends when I came to Sunset the other day. Yeah. Marco, what time does y'all's class end?
At 11:10.
11:10. I got there at 11:12, I think, right?
Oh, 2 minutes late.
I know. I was trying to hurry, but they have police on the toll road. You have to really kind of watch, I'm a law-abiding citizen anyway, right?
It's okay to speed once in a while.
Oh. This is a family show. You don't want to imply that we're lawbreakers, do you?
Oh, not really.
You're going to be at school tomorrow?
It's Good Friday.
Well, I know, for some people that's a religious day, is it? You going to be out for that?
Yeah.
Okay, well, we'll look for you next week then when you're back, okay?
Okay.
All right, we're going to do a Riemann sum. How do you like Riemann sums?
I don't really like them.
Oh, you're going to love them, okay?
Oh, okay.
I promise. You're going to love Riemann sums. All right, you ready?
Yeah.
We're ready. 10, 9, 8. There we go. All right. Estimate the distance traveled using a left Riemann sum. And here are my data points, okay? Now, it's a left sum, so I'm going to draw my data points over here. I kind of like to look at the graph. Well, that's kind of sloppy, wasn't it? 1, 2, 3, 4. At 0, we're at 70. And at 1, we're at 50. And at 2, we're at 30. And at 3, we're at 10. And at 4, we're at 0. We're going downhill, aren't we?
Yeah.
All right. If I want a left Riemann sum, I need to make a rectangle. Do I want to go here or here?
Left.
I want left.
Yeah.
So that means I'm going to use 70 for the height, and the base is how much?
1.
1. Okay, then I want a left Riemann. What am I going to use for that next height?
50.
50, and the base is still 1. My next height?
30.
And the base is 1, and my next height?
10.
10. And this time, I made it so that we had the same base, but they don't always, so you got to watch for that. It might be a base of 2 and a base of 5, right?
Yeah.
Okay, so what am I going to do to get the left Riemann sum?
Just add them up.
I just add them up. Would you do that for me? I don't feel like adding today.
160.
Excellent. Now, what are my units? It's feet per second times second. Very good. And it's stopping. It's how the car is stopping. So it's how many feet it took to stop. Did I get that right?
Yeah.
Tell Mr. Chasm to correct me. If I do it wrong, he'll have to correct me, okay?
He's kind of absent.
Oh, he is. Well, sometimes teachers have meetings and stuff. I appreciate you guys calling in. All right, you call back.
Oh, okay.
Thanks for calling.
Bye.
Who's our next caller?
James from Byron Adams.
Hey, James.
Hey,
How are you?
I'm fine.
Is that your real name?
Yeah.
Oh, okay. Brian Adams has a little history, right?
Yeah.
Yeah, just a little history with a fake name. But that was only one time, wasn't it?
Yeah, I think it was Ben.
I think so, too. Actually, I thought that was kind of funny. All right, here we go. I'm showing you a graph that you might have seen before. This is F prime. I'm going to mark it 3 times so you'll know, okay? F prime, F prime, F prime. These are little 1, 2, 3, 4, 5, 6, 7s, okay? It's a little hard to see that. This is the graph of F prime. F prime has horizontal tangent lines here at -3, here at 2, and here at 5, and a vertical tangent line at 3. I would like to know, this is F prime, I'd like to know where the second derivative is less than 0. My goodness, what am I asking for? The second derivative less than 0. What would that be? If this is the first derivative, where would you find the second derivative?
Slope?
The slope. Good job. Negative, 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 right? So that's from -7 to, what is that? Looks like -3. It's a little hard for you to see it. And where else? From 2 to...
Yeah, is that 5?
Yeah, I think so. I'm trying to decide if we need a break. But I'm going to go ahead and let that go. Everybody will tell me if I'm wrong, right? So I think we can go negative here and also get 2 intervals. So a lot of people tend to name what they see as negative. They don't realize that they're asking about the second derivative. And so don't just name what the picture looks like. Make sure you know what you're going for. All right, thank you for calling in. You guys call back.
All right.
Who's our next caller?
Jonathan from Skyline.
Hi, Jonathan. How are you doing? Jonathan?
Yes.
Who's your teacher?
Miss Johnson.
Miss Johnson. Have we got your picture?
Nah.
No?
Nah.
You don't believe in taking photographs?
Nah, I don't believe in it.
I see. So you have this thing about it's like your soul or something, right?
Sure.
Sure, why not? Okay, here we go. I got a problem for you. You ready?
Sure.
10, 9, 8. There we go. This is that same problem. I just won't let it go, will I? Y equals the square root of x, and y equals e to the negative 2x, and it's from point 3, 0, 0, blah, 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 to 1, okay? Now, here's my question to you. I would like for you to find the solid if the cross-section is a rectangle whose height is 4 times the base, and the base is right here. Can you tell me what the base is?
The base is
upper curve?
is the square root of x minus e to the negative 2x.
That's right. That's your base, and your height is 4 times that. Can you write the height?
That's right.
Well, it's just 4 times it, right?
Yeah.
That's not too hard a problem, is it?
No.
So how would I find the area? Well, I'd go 4 times what?
The square root of x minus e to the negative 2x times square.
Excellent. And then I'd integrate from that same little point 300 that I've just worn out to 1.
Yeah.
And that's not hard, but it was the first time we saw it because we were used to all these other fancy formulas, and this is just a rectangle, base times height. Hey, thank you for calling. You guys call back, okay? It's always great to talk to you. Well, once again, we've got our last caller. We're ready to let this show hit the road. How many callers did we have today, Rachel?
16.
All right, let's see if we got the calculator ready to go. 16 callers, and we're going to have winner number 1 and 2. Rachel, read them out.
They are Blanca from Kimball and Jessica from Skyline.
Blanca from Kimball, and Jessica from Skyline. I'll be delivering those this next week. Now, with tax going on, I'll try to deliver them where I don't interfere with the testing, but I'll get them to you. I hope you'll tune in next week for Calculus Live. You keep studying. Rachel and I are wishing you a 5 on the exam on May the 3rd. Work hard so that you can celebrate when you open that envelope in July. Bye-bye.
All right, thanks for tuning in for today's edition of Calculus Live. We enjoyed bringing it to you. And as a quick reminder, don't forget to send in photos of yourself and your class. We'd love to be able to show your face on television. Either mail it to us through interdepartmental mail at DISD Box 379 or drop us a line at calculuslive@dallasisd.org. For all of us here at Dallas Schools Television, I'm Daryl, and join us next week for Calculus Live, same time, same place. See you then.